Okay. Hello. How's everyone doing? Oh, how are you all feeling after your first P3 deliverable? You got the P3 gold spike in. You're now progressing on your P3 milestone 1. And how are things going? How does it feel to be on a much larger team? Team of 4, 5, maybe even 6? How does it feel, all? I'm gonna have to. It's hard to read the chat. I have to look at my other computer here. I might want to just get it going on my phone, maybe. That could work pretty well. Let's see, Twitch here. I don't get any anxiety recording playtests. Yeah, it can be kind of tough for sure. You don't have to worry too much though. Okay, there we are. All right. Has anyone watched or had a chance to watch their video feedback yet, either from their peers or from their instructors? Yeah? Tom W. Bush did. Shuo watched some. Yep. Has anyone seen any playtesters who got confused or maybe misread the directions or just didn't quite understand what they were supposed to do? It's the kind of thing that will drive you a little bit crazy as you watch some of this footage. Playtesters will find new, innovative ways to become confused, it can be frustrating. It can get you down a little bit. But remember that no matter what happens in a given week, no matter what your videos are telling you, you still have more time. Okay? You have more time. There's another week coming, a new deliverable on the horizon where you can resolve these issues, and hopefully you will. Okay? If not, you'll resolve them in the next build. That's just the iterative process, right? You see problems, you make tiny experiments to try and fix them, and then you evaluate whether it worked. And if it didn't, you come up with more experiments and you do the same process. All right? Eventually, you end up in a situation where things are going pretty darn well. But we have to be very careful that we have enough iterations and that we move fast enough to get our game to a good place before we run out of semester. The semester is the end of the semester is not that far away, everyone, and that might be kind of spooky, a little bit intimidating, but it is currently the 17th. On the 21st of next month, so almost 1 month away right now, is the final day of classes. April 21st is our showcase, if I recall. Let me verify that really quickly. Yeah, so April 21st is the final day of classes and our showcase. After that, this course is history. All right, so look forward to it. Okay, so some comments on your videos. I was watching through a bunch of them that you uploaded last night, and a number of the videos had audio issues. Before you start recording a bunch of feedback for your the games that you're playtesting, make sure that you kind of do a little experiment, record a little bit of your voice, and just make sure that the video that comes out of that has decent audio levels so you can be heard and understood, and make sure that the video is working as well, okay? If your hardware gets in the way and either can't provide decent video or can't provide audio, then send us an email and we'll approve you for just submitting a Google document with a bunch of notes instead, okay? All right, another thing is that when you submit your footage to the dev team, you're also submitting it to the course staff. We need to be able to see this submission so that we know you actually did your playtest. So make sure that when you submit it to the course staff, make sure that the permissions are set up so that A. Yarger at umish.edu, A. Renton at umish.edu, Ishwar, and Elsie Lowery, your course staff can actually look at these, okay? All right, thank you. So your grades have released for P3 Gold Spike. We aim to provide and get these feedback videos to you as early in the week as possible so that you have as much information as early as you can to create the tasks that you want to for that week. The earlier you get that feedback, the more informed you're going to be, and the smarter your tasks are going to be. Okay? All right. Another thing that's really important is that you should not allow us to design your game for you. As in your feedback videos, you're going to get a lot of suggestions, and your instructors, when you watch their video, they might provide some ideas for new game mechanics, some ideas for theming, stuff like that. And while that, can be helpful, you shouldn't take that as gospel. That isn't something you need to do. In general, we will help you identify your problems, and we will also try and generate potential solutions for you, a little bit of brainstorming for you. But don't let us design your game for you. It's your game, it's your projects. So please, embrace that. All right? Okay. Some news. Oh, this isn't really news, but I think this happened last semester, courtesy of Jason Rubin, who is a Wolverine. No, not a Wolverine Soft alumni, but a Wolverine alumni. Facebook has gotten into the streaming game, or at least they're getting into it. I'm not exactly sure how they're doing it, but I joined Facebook Gaming as VP of Play, and we're rolling out our take on cloud gaming, instant free subscriptions, no controllers. So it's really, really unclear what they're talking about here, but I assume eventually they will roll this out and explain to everyone what they are talking about. This is to say that Facebook is getting into cloud gaming. Much like Amazon and much like Google before it. It has been very interesting to see all of these traditional tech companies trying to jump into games, and for the most part, not doing so great. But it is really, really cool to see that level of investment. Clearly, these big, powerful organizations think that there's a big, long, interesting future in the world of game dev. Okay, so one of the funny things that you may not realize, most of you, I assume, have heard of the game Doom. It's a classic first-person shooter, one of the first. And one of the interesting things about Doom is that its code base has been open sourced. And so one of the early benchmarks that new hardware and systems can get, particularly if they too are open, hobbyists will go on and they will try and see if it can run Doom. All right, and this can be extremely surprising. So here's the source code for Doom. You can look through it if you want to. You can compile it if you want to. And you can read from John Carmack on the topic of how this code is kind of organized. But as it turns out, voting machines can run Doom, which is kind of interesting. Yeah? There we go. It turns out our juicers today have gotten so complicated that they have the capability to run Doom if you truly want to. And I think this is a video too, so... okay. Yeah, so you can see the players using kind of the laggy touchscreen on this juicer to try and control their character here. It's not going super well, but if you were on a remote island and all you had was a juicer, then you could play some Doom maybe. Okay. So can microwaves, apparently. Microwaves have gotten sufficiently advanced that they can run Doom. So that's pretty exciting, I think. Okay, so I think part of it comes down to just the way that Doom source code was written. It is apparently it was written in a very, very, very portable way, and it also has extremely low rendering and computational requirements. There are ports of Doom on the Super Nintendo, right? A super, super old and cheap and slow 16-bit console. So anyway, it's kind of a cool benchmark. If it can run Doom, then it might be considered truly interactive, whatever your hardware is. Okay, so as it turns out, we were just talking about Jason Rubin, who's a Wolverine alumni and founder of Naughty Dog. He created Crash Bandicoot, and Crash Bandicoot was really interesting. There's a documentary I found on how Crash Bandicoot was made, and in particular how its data was organized on the disk to allow for this beautiful world to be streamed from a really, really, really slow storage medium at the time. So I'll show you just a tiny bit of this to get you intrigued, and then you can watch the rest if you are interested. Okay? How Crash Bandicoot hacked the original PlayStation. Oh, this is really crazy.
Bandicoot that I took to. Memory was so short in Crash Bandicoot that I took to stealing little bits and pieces of extra memory from the Sony libraries. I would just try erasing parts of them that I thought I wasn't using and see if things still worked. If they did, I would mark them as available. I just hacked their code by just changing the byte codes. And I'm like, you can do this. Look, I fixed it. If they wouldn't fix it for me, I was just gonna edit their code. It was free memory. The memory was finite, but you were definitely not supposed to do that. Hi, I'm Andy Gavin, co-founder of Naughty Dog Inc. and lead programmer on Crash Bandicoot. We set out to make the first 3D character platform action game, and to do it right, we had to literally hack the hardware. It was part of the Naughty Dog philosophy to leave no stone unturned, no cycle of CPU or GPU or byte of memory that you could use unused. So if it existed there in the machine, whether we were supposed to use it or not, whether you had to use some crazy trick to use it or not, we would figure out how to make the most of it. So in the summer of 1994, my partner Jason Rubin and I were wrapping up Way of the Warrior, which was our 3DO fighting game. And we were trying to figure out what kind of game do we want to make next. The biggest genre on consoles at the time were platform action games. Games like Super Mario World and all sorts of other classic 16-bit platform games. And at the same time, in the arcades, there was new 3D hardware, and certain genres were making the transition from their traditional 2D state to 3D.
Okay, we won't go too much further into that, but I encourage you to watch the rest of the documentary. There's some really, really interesting technical tricks that are really crazy, to be honest with you, that they had to do to get such a beautiful launch title going for the PlayStation. I'd just like to reiterate what Andy talked about at the very beginning. They were so pressed for memory on Crash Bandicoot on the original PlayStation. Their RAM, it was so small that they began to edit the official Sony library that was loaded into memory when the game started. And so they didn't even have the source code to this library, so they didn't exactly know what they were messing with. But they just said, you know what, I'll bet we're not using all of this library, and so they would just kind of rip out chunks of it and hope the game still ran, and they would use that space that they ripped out as their own, right? Mine now. I wonder what the Sony engineers thought about that when they heard about it. I also have to wonder about the status of their relationship if, one of the more important games in Sony's history had such a hard time getting the source code to some libraries that they were using. That seems very, very strange to me. But anyway, let's go ahead and keep going. I encourage you to watch that documentary. It's really, really interesting from a technical perspective. Okay, why feedback and iteration is important. It wasn't that long ago that we had this wonderful, wonderful trailer come out for Sonic, the movie. If you recall back in the day, when this image and trailer came out, there was kind of an internet party on just how terrible and uncanny this looked. We had Sonic here with the human teeth. We had Sonic with the really kind of strange eyes. It looked not necessarily like the cartoony Sonic character that has been known for ages, but it looked kind of like a human in a Sonic suit. I saw that movie in theaters on Valentine's Day last year. Yeah, and so what's really interesting here is that the outcry was so intense and so memey that the studio went back in and said, okay, we're going to reanimate the entirety of the the main character in this animated movie. And that was not cheap, but the result was much better. They basically got the message that, okay, we need to just go and cartoonify this character so that it's no longer in the uncanny valley. It's on the precipice of it, maybe. But yeah, ended up being a pretty good movie, pretty well received. So yeah, that is the power of iteration, and that was really only one cycle of it. So there you go. Okay. Oh, this is also why you want to have the most kind of diverse audience you can when you're playtesting. It's a little bit hard to imagine that this first version, probably got through many iterations internally at Paramount, and no one ever brought it up or said this is going to be a humongous problem until they were forced to iterate with a much wider and much more diverse audience, and they discovered the bubble that they had been in. So anyway, yeah, do what you can to try and test with not just the same people every single week, but also with your friends and family, and also maybe you post your game online every once in a while. See what people online feel about it. Okay, let's keep going. The Uncanny Valley is a bit tricky. I don't remember exactly what this image is. Yeah, right? So another comparison here. Okay. All right. And a quick note, this week with your assignments, they are going to be changing a little bit. So this previous assignment has mostly been about your gold spike. So have you identified what your most important mechanic is, and have you implemented it and completed your game loop? Now, and from here on out, your assignment rubrics are going to have a lot more criteria on it. You're going to start getting the guidance criteria. You're going to start getting the interesting decisions criteria, technical criteria, stuff like that. And more will actually come in every couple of weeks. Soon you will have a professionalism criterion where you will be graded for whether or not you have things like scene transitions, whether or not you have things like audio and sound effects, stuff like that. So please keep an eye on the rubrics themselves. It can be very, very tempting to just look at these, to just look at the schedule, right? The schedule, however, does not get you to the actual rubrics that control your actual grading. So instead of just looking through the schedule to get to your assignments, please make sure to go into Canvas, find your assignment, and you'll also find a rubric there, along with an exact, precise due date and like end date, cutoff date. If you don't see a due date and there's no announcement on Piazza, you can assume that the deadline is 12:30 p.m. Eastern Standard Time for all of these deadlines. Okay? All right. Okay. So, very, very little is changing for P3 Milestone. P3 Research is essentially the same as P2 Research, with the exception that there are a lot more games that you need to compare. So if we look at the template that you need to complete, this is a 5-page minimum paper, and almost all teams will go over that amount. But you will be tasked with kind of deciding as a team what genre are we likely to be in with our Project 3 game, and then you want to grab 8 games from that particular genre, okay? You want to grab games from your game's genre so that you are making meaningful comparisons. It is not so helpful if you are trying to make a platformer, a 2D platformer, and 3 of your genre games are from the rhythm game section. If you are making a game similar to Mario Bros. And you decide to research Rock Band or Guitar Hero, that is going to raise a lot of eyebrows, and you're probably not going to learn much of anything. Unless your platformer is also a rhythm game, so a rhythm platformer hybrid. That would make a lot of sense. But anyway, you have 8 games that you need to find, and then you compare game 1 to game 2, game 3 to game 4, 5 to 6, 7 to 8. I recommend that you split this up, and you come back together at the end of this assignment to kind of discuss what you learned, okay? All right. Okay, so something that has become clear is that a lot of games in this course are dealing with some form of enemies. Often the enemies need the ability to actually navigate and chase down the player and become a nuisance for the player. And if you don't know that Unity has built-in kind of navigational AI systems, then you can spend a lot of time and effort for potentially a worse result. Toward the end of this class, we will talk a little bit about how these algorithms are implemented using things like A*, using advanced pathfinding and search algorithms. You can also learn more about these kinds of things in EECS 492, the artificial intelligence class. But today, what I'd like to do is I would like to just do a quick example, kind of showing you how can you quickly get this kind of stuff up and working. Since I know many teams need this kind of technology, and some teams don't know about it. So let's go ahead and we're going to create a new little demo here. Let's go ahead and create a new project. Boop, boop, boop. Okay, pathfinding demo. Cool. Okay. And we'll go ahead and get this going. Question, chat. Did you enjoy the a couple lectures ago we had a lecture in which we actually had some music running during the actual main portion. In fact, I think it was classical music, and for one section it was kind of study music. Study music lo-fi? Let's see how that goes. And what I'm wondering is, did anyone like that? Was that a win? Was that a loss? This is very calming, isn't it? I kind of like it. Big W. All right, and it's very easy to just turn this on and just kind of chillax to some pathfinding demonstrations. Oh, this is taking a while to launch. Unity, come on. Yeah, you're gonna have to guess which channel I jumped into here. Oh gosh, this is taking a very long time. I think I may regret having not preloaded this. Here we go. So chat, while this boots up, question, are there any topics out there in terms of implementation that you would like to see us cover in kind of mini lectures in the future? Is there any particular bit of knowledge that you're seeking? If it is the kind of knowledge that we think will have a widespread impact in this course, then we can justify doing it. It's a little bit hard since everyone's working on different things to create a lecture that's going to be helpful for everyone, especially now that P3 has started. But go ahead and put in any suggestions you've got into the chat, and I'll review it after the lecture today, okay? All right, so let's go ahead and get going. We have this empty scene here, and let's go ahead and get some basic things set up. We're going to set up a quick 3D environment, get us ourselves a cube here. We're going to bring it back to the origin. Let's make it 20 and 20. Let's go ahead and get some materials going so it doesn't look too bad. We'll get some green going. Let's try over here. There we go. I'm going to drag it in. Let's go ahead and get some sort of obstacle going. We're going to get another 3D cube here. We're going to move it to the origin. Boom, boom, boom. We're going to make it a little bit bigger. How about 5, 5, and 5? Okay, so we got this nice little block here. We're going to give it the color red. Actually, let's give it the color blue. Red-green color blindness is pretty common. Here we go. Boop, there we are. I do not like this color palette. This looks very like McDonald's Play Place, I think. Like the colors are really vibrant and they're not necessarily in a good way. So actually, let's do something like this. let's go a little bit washed. No, let's go a little bit dark, a little bit muted maybe, like that. We'll then copy this same color to blue over here, but we will get back to blue by simply changing the color wheel, right? So this looks a lot more cohesive. All we did was change the hue. The saturation, the brightness stay the same across these two colors, and as a result, they feel a little bit more cohesive. There's a little bit of a color palette going on. Okay, so let's go ahead and save our scene, and now let's go ahead and create our little character here. So let's create a capsule. We're going to bring this this little person up here. We've got our capsule. It's embedded in the ground right now, so we'll bring it up. Let's go and add some eyes to this capsule so we can see where it is looking. 0.25, 0.25, 0.25. On the x-axis, let's get this to 0.5. But what we have here are now goggles. There we go. That's kind of cute, isn't it? Okay, so what we first need to do if we want to set up some of Unity's built-in, quote, air quotes, nav mesh capabilities is we want to import a repository. We want to import a repository called the nav mesh components. And let me go ahead and shrink this over here. This is an official Unity provided, but not built-in, repository of some tools that can really help you get up to speed quickly when it comes to the nav mesh. Okay? It has a bunch of components, the most important of which is nav mesh surface. So we can go ahead and grab ourselves a copy of this repository, download zip. Actually, I think I already have a copy downloaded here. Here it is. What you'll find is that this is actually an assets folder because this is actually a Unity project when you open it up. So it looks basically like this. Okay, I recommend you rename this. Let's just call this nav mesh components. And we are going to go ahead and drag this into our Unity editor. We'll just drag this right into our project. Did we get a bot? Animation clips. Yes, so the animation system in Unity is very powerful. I don't tend to use it all that much unless I'm working with 3D characters. In part because I often like to just use math to get some basic animations going. But we can probably explore that a little bit later. Okay, so now what we have is a basic environment, and we have a basic character here. We'll do some renaming and reorganization real quick. Let's call this an enemy. This is our enemy pill character. And we want this structure here, these two objects, to form our geometry. So let's call this a level geometry. And we'll go ahead and center it on the origin, and then we'll go ahead and throw our objects in. Okay. So the nav mesh surface component, if you think about the name of that component a little bit, you might gather that it is related to the environment. Nav mesh surface. It is the component that controls and defines what surfaces are part of your nav mesh. So we'll go to the root of our kind of level geometry here, and we'll add nav mesh surface right there. Now, this component comes with a few controls on it. You can see that we have the ability to clear our nav mesh data, but we also have the ability to bake. If we click bake, we get this really cool little visualization here, where we can see the nav mesh that has been created for this particular area. Something that's really important, though, is we need to change this nav mesh surface to say, hey, only include children, okay? Do not use every game object in the scene for this nav mesh, only use children. The reason is that before you saw there was this hole in the nav mesh where our enemy was. That's because it looked at the enemy and said, hey, here's an obstacle, and built the nav mesh around it. By switching this to only consider children objects, it will not consider this little character here as part of the obstacle set. And so now we have this nav mesh that will kind of works its way around this obstacle in the center of our area. And if the agent can get on top of this block, it can actually walk around on top of this as well. Okay, so that's cool. We have this nav mesh. It is this set of polygons essentially that form this kind of blue area that Unity agents will know how to walk around. But how do we actually use it? So if we look at our enemy, it currently doesn't have anything relating to the nav mesh. And if we just play the game, I mean, it's not going to move around. There's nothing on this enemy game object that is relating to movement. So we need to upgrade our enemy a little bit. The first thing we're going to want to do is we're going to want to come in here into the corner. Actually, you're being blocked a little bit, aren't you? Let's go ahead and put it over here instead, so you can see a bit better. Okay. Okay, so let's do a couple things. Let's create a kind of mock player game object. This cube right here is going to be our player, and the enemy's goal is going to be to run to this cube. We'll go ahead and call it player, and we're going to get rid of its box collider. So it's really just a rendering token that we can move around at runtime to kind of see how the AI works. We'll move it over here so it's on the other side of our enemy. Okay, when the enemy kind of spawns, it needs to start navigating. Now, Unity provides a really cool component called NavMesh Agent. It has a lot of stuff built into it. It has stuff like speed, angular speed, acceleration, obstacle avoidance properties. You know, what kind of radius should the agent kind of swing around when it's going around corners. But it won't work on its own. We need to write a little bit of code that will inform this agent and tell it where to take us. Let's call this desired position is player. How about actually, let's do this. Desired position is game object. Okay? That's a more generic component that we can write. So we have a new component. Desired position is game object. Let's go ahead and write a little bit of code here. Not too much, don't worry. How to create tension or a sense of urgency. That's really, really tricky. It is something that we struggled with a lot in the Greek tragedy demo that we put out not too long ago, but I do think we achieved it pretty well there. This is something that we would be talking about today if it were October, because we do our horror lecture in October, but that only happens in fall semesters and not winter ones. You're not missing too much, though it is kind of a fun little lecture. Okay, so what we need to do is we need to, when the game starts, we need to launch a little routing loop, okay? We're going to make this into a... Uh-oh, where's our autocomplete? There we go. Let's call this the pathfinding loop, okay? And every second or so, you'll return new wait 4 seconds. We're going to wait a second, and we're going to go into an infinite loop, okay? So this is truly a loop. At the end of every iteration of this loop, we'll wait for 1 second. So this will not lock up our game. We're going to make sure that we launch this as well. All right. Now, the inputs to this component... this component is named desired position is game object. So we want the game designer to be able to specify the name of a game object. So let's call this just target name. Every single iteration of this loop, which is going to happen 1 time per second, we are going to see if we can find that game object. So game object target game object equals game object dot find. And we're going to submit this particular name. So what is the compiler complaining about here? Cannot convert from IEnumerable. Oh, sorry. IEnumerator. There we go. So every single second, once this game starts, every agent is going to look for whatever game object we tell it to look for. Now, if it finds this game object, then we need to do something. We need to tell our navmesh agent component to take us there, okay? Target go is not equal to null, as in we found our game object. We need to grab a reference to our navmesh agent. It doesn't exist though, so we need to include something at the top. We need to include the AI module. So we're going to go navmesh agent. And let's go ahead and use it. We need to fill that reference here. Agent equals get component. Navmesh agent. We want to be defensive here, so if we launch into this loop right here and we don't have an agent, if it's equal to null, then we want to tell the developer that something has gone wrong. Let's call this desired position is game object dot pathfinding loop. This game object is missing a navmesh agent. Maybe a better way to do this though, and then we need to bail out of this loop, yield break. Maybe a better way to do this though would be to do require component type navmesh agent. There we go. All right, so now this is a pretty defensively written component, so that's really good. Now we can actually use that agent and we can tell it where to go. So let's go ahead and set our destination. It's simply going to be to the target game object's position. Okay? All right. So let's just make sure